Hello all. So I hope you can hear me well and that you like the course so far. If you have any feedback, you can type that in the chat. And I hope you will stay until the end of this course and that this full course is going to be useful for you. So today we're starting. We're just starting. Then we'll go on with it in other live streams. But we're starting with understanding how classes work. But first, we have still this topic, packages and imports. So we'll do this one first. Just a brief reminder: you can find on my website the slides of the course, and I have finally updated it with types. So starting from lesson 4 until number 8. And here we will find all useful information that you have seen in this course, and you will have a quick recap if you want to go through it. Okay, so here you have basic types, then you have Boolean, characters, strings, then you have arrays, then you have type checks and casts, and then you have a new topic, which is control flow from lesson I don't remember, probably it was here, lesson 7 and 8. So um, sorry, probably this is lesson 8. So if, when statements, when with expression, and then as a statement, and then when with no subject, then you know that when can be used with seal classes, enumeration classes. Then, basically this is a very versatile condition checking type that you can use in Kotlin. Then we have seen for loops, while, do loops, and while and do while loops. And then we have seen returns and jumps, and then exceptions in our 9th lesson, which is not here, sorry. And so here's another recap on everything, and then we have seen also the nothing type, and that's it. So now let's get back to packages and imports, and let's see what they want to teach us on this. So a source file may start with a package declaration. So package is always declared on the top of the file. As you can see here, I have created a new class, and the package is automatically given when you create a new Kotlin file, so you don't have to type it, but basically it's the name of the source name of the folder. And we have already seen some time ago that you may use a different package name, but it will say with a warning that it's not matching the file location, so you have to keep it straight. All the contents such as classes and functions of the source file are included in the package, so everything that you place inside, like a function or a class or a variable, will be included in the package. And that's it. If the package name is not specified, the contents of such file belong to the full package with no name. Alright, I see an error on YouTube. Let me check. Okay, that should be okay. Probably there was an issue with the stream, but that's no issue. Okay, so probably there was an issue with the network, but it should be fine. You should be able to listen to me. So as we said, here, if I delete the package name, it will belong to the main package name. So we can still do that. And it will belong to probably org example, but I'm not sure. We would have to to create a package and see it from analyzing the package to make sure what it's doing, but we don't have time now. So default imports, so number of packages are already imported into every Kotlin file. So if we access any of these classes like annotations, collections, comparisons, IO, so input output, and ranges or sequences or texts, we will be able to have all access all the functions and variables from these packages without having to import them. So yeah, apart from the default imports, each file may maintain its own import directives, and you can import a single name file. So for example, we have a data class customer that we had created here in the past, so I will use this as a reference. And what I can do is say, okay, import our example, and then miscellaneous, and then I can say customer, and then it will import the class for me, and then I can use it. So usually you have seen me doing this in another way. Okay, so it's not needed to use it here because we are already in the same folder, but by switch folder, it should warn me. Yeah, it should be required. So I will say classes, and I will put it here. Yeah, it's still not needed because we are in the same package. So probably if I switch package, it will ask me to yeah, it will ask me to import that. We'll see it very quickly. Oh, it's still not needed. Maybe let's try and switch this. Okay, so as you have seen now, I am in org classes and not in org example anymore. And now it's required, since we are in a different package, to import the package. So if I delete it, it will complain. And anyway, all the time I use the import suggestion from the IDE because, I mean, it's very long to type this anytime. So my suggestion is to use the IDE suggestions. What you can do as well here is you can say I want to import everything. So as you have seen here, we could have imported numbers from here, like I don't know. We can print okay. So object okay. So in order to do so, we could say import all, because I want both customers and numbers. And now here inside the name, I will type OK. And then you see that I am able to access this OK, even though I am in a different package, because we are importing all the stuff from this package, and basic type is contained inside there. Next, let's see. Okay, so you can also use the as keyword. So if you have similar like classes or I don't know, interface or whatever, you can say, okay, the first one will be message and will be accessible, but the second one will be with the as. And this way you can use them both. So let me create a data class customer, but this time I will create it here. So customer.kt, and now I will say data class customer. And yeah, it should have a parameter, so I will say customer name just to differentiate it from the other class. And this is possible because we are in a different package, as we said. So we're good to go. Yeah, maybe I will just rename these to not to example, but secondary package. Then we have to rename all of these. Okay. Now, what I want to show you is that if I import or dot secondary dot customer, it's going to be, yeah, maybe we have different constructors, so it's understanding that, yeah, it's understanding the difference between those, so we're pretty safe. Aha, so you see here, if I import them all, it's okay. And if I say, okay, I want to import just customer, email, then it's going to complain. And what I can do here to solve it is to use as miscellaneous customer. And then this way it's going to be okay. And I can replace miscellaneous customer here and use both the entities, both the data classes, sorry. So we can actually try this. We can print line here and print line there. And then print line here, run. Come on. Okay, the import keyword is not restricted to importing classes. You can also use it to import other declarations, such as function properties, object declarations, enumeration contents. Yeah, I don't know why contents. Yeah, enumeration classes. And if a top level declaration is marked as private, then it's private to the file and you cannot use it. Maybe we can see it now. Yeah, as you see here, we are using the first data class here and the second data class here, and they're giving different results because they come from different packages. Good. Next, we're going to see the private. So I'm using the file inside the secondary customer, and I'm saying private function print customer, and then I'm going to say print line hello customer, and then I'm saying customer called customer with test name, and then I'm printing him. And basically what I want to show you here is that if I try to use this function, let's get here. If I try to use this function, it's going to say it is private, and in order to use it, I either have to use the internal or public modifier. If I use the internal, then it's going to be accessible by the same package name. In fact, I want to show this to you, but if I go to app and I try to print it here, it's going to complain because no, it's not going to complain, sorry. It looks like we are in the same package. So org example. Yeah, we are actually in a different package, but it's allowed. Probably the code is shared anyway in this case. So the modifier internal is okay because we are in the same, I would say, hierarchy folder. Probably if we use a different module, then it's not going to be accessible if it's internal. Okay. So let's now start with the topic of today's lesson. Sorry for being a little bit long on packages and imports. The topic of today is classes. That is one of the most important topics in objective programming. And so classes in Kotlin are declared using the class keyword. Okay, we have seen this. The class declaration consists of the class name and the class header specifying its type, parameters, primary constructor, and some other things, and the body surrounded by curly braces. Both the header and the body are optional. In the class has no body, the curly braces are omitted. So you can create actually a class without a body. So we can do it here, empty class, and it's going to be fine. Also, if you try to declare it, it will say it's redundant. So you can remove the constructor in that case. All right. So let's go on. So we have I didn't I don't know if I said constructor, but I forgot what I just said. Anyway, now let's start with the constructors. A class in Kotlin has a primary constructor and possibly one or more secondary constructors. The primary is declared in the class header and it goes after the class name and optional type parameters. So what, yeah, let's do it on classes and not data classes, which are a variant of it. So let me create a new class. Like I have an example here, like let's say online course.at. And now we're going to say class online course, and then we're giving it a course ID and a course name, right? So this is the primary constructor or of the class. What this means is that if I try to use this this class, so online course, I try to initialize it. Since the primary constructor contains course ID and course name, so I can say one Kotlin course. Then we have to declare all the parameters of the primary constructor in order to create an object of that class. Okay, an instance of that class. Sorry. So that's what we have seen now. If the primary constructor does not have any annotations or visibility modifiers, the constructor keyword can be omitted. Okay. So basically, you don't need to type constructor inside after the name of the class. Let's try and do this constructor. Yeah, as you see, it's going to be redundant. because we don't have any annotations or visibility modifiers. So internal class. All right. I wanted to check something, but looks like it's okay like this. So the primary constructor initializes a class instance and its properties in the class header. The class header can't contain any runnable code, so yeah, you cannot put any runnable code inside here. If you want to run the same code during creation, use the initializer block that we'll see in a second. They are declared with the init keyword. Write any code that you want to run within the curly braces. Okay, so during the initialization of an instance, the initialize block are executed in the same order they appear in the class body, intervalled by property initializer. Okay, that's interesting because in this case we have actually two initializers. Didn't you know you could do that? And you can actually have them one after the other, so they will be executed first init, and then we have second init, and then we can declare some inner variables here, like duration in minutes, and we're going to say this value is 0. And then what we could say is val duration in seconds, and then we're going to say duration in minutes, 60. And here I'm going to say, instead of this, I'm going to say get, so that anytime we call duration in seconds, it's going to be computed against the new value that we will have in duration in minutes. And now I will say, okay, print here the duration in seconds, and here the duration in minutes. I don't think I can print the duration in seconds. Yes, I can. Okay, that's interesting. So let's see the result. Okay, so we have the result here. As you see, when I'm printing the class, I'm getting the instance address actually, because with classes, data classes have their toString overridden, as we have seen in a few lessons ago, but normal classes do not have this, so actually printing the address. All right, let's go on. Primary constructor parameters can be used in the initializer blocks. They can also be used in property initializer declared in the class body. So inside the class body, which is this part, we may execute some functions that change the actual parameters. So for example, I can access in online course, I could access course name, and I could have it all in uppercases. And I can say course name uppercase. And then of course, I can print it. Right, so let's run it again. And we have Kotlin course in uppercase, which is, as we have just seen in here, we have seen that it's this parameter that we passed with the uppercase. Okay, thank you. Next, we have concise syntax for declaring properties and initializing them from the primary constructor. And we can also include default value. So, these are known as parameters. So let's see what course ID is here. So I will print online course ID. So as you see, this is not a member property, but it's just an argument of online course at the moment. And you cannot access this this value unless you declare it as a value or a variable. So if you declare the property, then you're going to be able to access it from outside the class. So let's make this clear. So I want course ID to be internal. I mean, I want this to be just an argument, and I don't want it to be seen from here, but I want the course name to be seen here. So what I'm going to do is I'm going to say this is a value, and this way, as you can see, also the IDE is suggesting me that it is possible to access it from the instance of the class. So let's print this course name, and now we're going to see that it's possible to access it. I have an issue. Sorry. Okay. Okay, now it's possible to read this value, and let's try to do the same with course ID, and let's see which error we're getting. So unresolved reference course ID. Let's run it. So a compiler failed unresolved reference course ID. That's interesting. That's because the argument that we passed is not declared. Argument that we are passing is not declared as a value or variable. So of course, now that we can access course name, let's create a new parameter to showcase another thing, like instructor string, right? So the instructor name, of course, will be Luca. But what if we want the instructor name to change? And instructor name changed instructor name, and we try to change it from the instance of the class instructor name. I want this to be Ettore and not Luca anymore. And as you can see here, it will say value cannot be reassigned, so we have to change it to variable in order for this to work. So let's change it, and now we have a variable here and a value in course name, which is not going to be changeable. And now, yeah, if I type println, which is a little bit more readable, we should see the instructor name has changed to Ettore. Yeah. And that's fairly nice. So yeah, of course, at the end, you have seen me using the trailing comma, and it's needed. Um, if the constructor has annotations or visibility modifiers, the constructor keyword is required, and the modifiers go before it. So if you want to use modifier like, yeah, private constructor, we'll see this later, but like if you want to use a private constructor, then we will have to use the at inject. Sorry, you will have to use a constructor keyword. Sorry. Then in Kotlin classes you can have secondary constructors. So let's try and create a secondary one, which are prefixed with the constructor, of course. So as you see here, if there is a primary constructor, which is our case, each secondary needs to delegate to the primary one directly or indirectly through another secondary constructor. Delegation to another constructor of the same class is done using this keyword. Perfect. So let's showcase the example here. I will have the platform as another argument of my constructor. So let's do this. Let's say constructor, and then we are going to say platform string, and we have this because we have to delegate to the primary constructor, and then we have to type here course ID, and yeah, all the things that we want. So yeah, this should what we should do is the following. Let's do course ID. So we have to have more than what we have declared in the primary constructor, otherwise it won't make a lot of sense. In this case, instructor name, and then we pass all these here. So I'm not using a value variable or whatever. I'm passing only the arguments in this case. So I'm not using val or var here because we will invoke the primary constructor now. So course ID, course name, and instructor name. Okay. And what we might do now is we might have a body in the secondary constructor that does something else with our platform. So let's see also if platform is already accessible here. It is not, because we have a primary constructor which does not have the information of the platform. So what I can create is the platform nullable here, and this is going to be a nullable string initialized as null. Right. And yeah, probably it's going to be a variable, and then we're going to say, okay, the platform nullable here in this case, if you use the secondary constructor, is going to be what you pass in the secondary constructor. Perfect. Now I can print it. So yeah, now this becomes a little bit stupid to have it. So I will comment this. Where is comment here? I don't know the shortcuts of this IDE. Unfortunately, I have to learn them. Nice. Keyboard shortcut PDF. So where is the comments? Navigation, editing, completion. Go to line. I don't know this. Where is it? So let me check. Complete comment finds. To comment several lines. Control C Shift Flash. Let's see if it works. Control Shift Flash. Yeah, it did work. Okay, so Control Shift Flash. I have to remember this. So thanks for waiting a few seconds. Now what we had to do was to print out platform nullable, and we're going to print it in our primary constructor, and we're going to run the code. So what you expect is that you have a null value because we're not using the secondary constructor. And for this purpose, we're going to create a new online course, number 2. And we're going to say Flutter course. I mean, why would you learn Flutter? No, I'm just kidding. But it's probably a very nice programming language, and I have to learn more about it. Let me print it in case we're using the secondary constructor. So platform is going to be YouTube because guys, we're on YouTube. Okay. So as you see here, I'm passing platform now. Oh, just to show it a little bit better. Okay, great. And I'm going to say link the platform. Anyway, yeah, as you see, I mean, this platform cannot be is a value parameter, as they say here. So you cannot access this directly from here. What you might do is you might access platform nullable and make this a non-private variable. This is what you could do. But let me try something just to understand. Yeah, as you see here on second, what I expected was that on secondary constructor parameter, value or variable is not possible. You cannot use it. You can only use value parameters in these cases, which makes sense because otherwise, when you use the primary constructor, you don't know about the existence of value or variables inside the secondary one. So I hope this is clear. So if I try to access here, as you see, private, so you cannot do it. So I'm just going to run it because we have the print on the initializer. So, okay, why is it now? This is quite strange. They say, yeah, platform, YouTube. I'm passing platform. Platform nullable is going to be changed. and then it runs. Yeah, probably it is running the initializer before the secondary constructor. I'm not sure about this behavior. Let's see if they say something about it. So if this class, okay, here, delegation to another constructor of the same class without using this. Parent children. So here they're adding to the parent a children. Code in initializer blocks effectively becomes part of the primary constructor. The delegation to the primary happens at the moment of access to the first statement of a secondary one. So the code in all initializer block and properties initializer is executed before the body of the secondary constructor. Perfect. So we have just discovered this in our example. So this is going to run after the init block. And in fact, if I print line here, after init block, so yeah, that's right. You see it here. We're running the initializer init after the secondary constructor. So logically speaking, I would say that it's better to place the initializer before, just for you to remember that initializers are run before the secondary constructors. Perfect. So what if I want to see the result of, yeah, I want to access platform? Then after we run the secondary constructor, we can see it. In fact, if I remove this and I have an internal variable, then if I try to print it here, online course 2, then platform nullable, we're going to be able to access this, and we're going to be able to see that it's actually properly initialized. So let's see it with the run. Where did I make a mistake? Must be initialized. Ooh, per platform. Oh, am I using course 2? Yes. Okay, that's because, yeah, I was trying to print it on the init, and I have this variable over here. I have to place it over here first. So yeah, it makes sense because I'm trying to access it on the initializer. Now, as you see now, yeah, we have platform nailable as YouTube inside here. Great. So that's very interesting. If a non-abstract class does not declare any constructors, it will have a generated primary constructor with no arguments, and the visibility will be public. If you don't want your class to have a public constructor, declare an empty primary constructor with no default visibility. So Yeah. I mean, what's the purpose of having a private constructor? We would have to check if we can have it here. Yeah, maybe if you want to have a new like let's say that okay, constructed a primary constructor call is expected. Okay, perfect. We have to do the same we're doing here. And we have to do all of these. What might happen is that you may want like a platform capital, and you want to this constructor to be used only by our secondary constructor. I mean, this is constructor nesting, but and it's probably not very nice to do in. So I would say in private constructor. Let's see if let's do this. So I'm copying this, and I'm not using anymore this, but I am trying to call the constructor. I don't know if this is possible. Nope, I don't think so. I have to pass platform here, and then platform upper case, and then yeah, it's going to refer to this constructor, this private constructor. So basically what I'm doing is after the private constructor, just to showcase this, I'm using a private constructor called by our secondary constructor here to pass in a platform with uppercase. Platform uppercase. And I will type this also here for you to see it. Let's run it. Let's hope it works. Yeah, it does. So as you have seen, what I was doing here was I was using the private constructor to pass in a platform with uppercase, and this time I'm calling this, which is the primary constructor. And so we are entering here, we are in a private constructor, we are printing our platform nullable and uppercase. We're instantiating the platform nullable with platform, and then after that we're going back to this constructor, and we are now after the private constructor, and then we are printing the platform nullable. So I hope you understand this flow, and it was clear enough. Okay, so on the JVM, if all the primary constructor parameters have default values, the compiler will generate additional constructor which will use the default values. This makes it easier to use Kotlin with libraries such as JSON or JPA to create class instances through parameters. Okay. So that's nice to know actually. Create instances of classes, so you can create, yeah, we have done this, and we don't need a new keyword as in Java. So class members, yeah, we can contain constructors and initializer blocks, functions, properties, nested and inner classes, and object declarations. So we have seen already all of these topics in our course, but we will go more in details in the next lessons. Classes can be derived from each other and from inheritance hierarchies. An abstract class may be declared abstract along with some or all of its members. An abstract member does not have an implementation in its class. But yeah, you don't need to annotate abstract classes or functions with open. So yeah, like rectangle is a type of polygon, so it's going to be inheriting from the abstract class. And it will override the draw function. Then you can have, you can also override a non-abstract open member with an abstract one. So suppose that you have an open polygon, then you can have an abstract class white shape, which inherits from polygon which is open, and then you can create an abstract override function of draw. Okay. Then you can have companion objects if you need to write a function that can be called without having a class instance, but that you need access to the internals of a class, you can write it as a member of an object declaration inside a class. If you declare a companion object inside your class, you can access its member using only the class name as qualifier. Okay. So we have seen companion object last time. I don't know if they have more specific examples on abstract classes. Yeah, so we might we might say that we are inheriting from an abstract class called course, because these are online courses, and we can create course.kt, and we can say create class, extract to separate file. Okay, and we have it here now, and it's automatically declared as open. And what we can do here is we could say, let me see, list students. We don't have that, but on list students, and that's it. So what's nice about this is that I can have it as an open class. So this class is actually can be used to create an instance of it, like of course. Like any course. Sorry. Any course, and we can print my. Yeah, we can say any port dot students, and here we doesn't make a lot of sense, but maybe based on prefix. So macro, Mirko, and so on. So we can list the students and print them. I will mess this up. Template string, perfect. List of students. Okay, now we have the list of students, and we have this with an open class. But what if we make an abstract class? Abstract course.kt. Here I'm going to create an abstract class abstract course, and this time I'm going to say abstract list of student function, of course, and I'm going to initialize it. Oh gosh, that's what it's going to say. A function with body cannot be abstract, so you either have to declare it as non-abstract, and then here we'll have the same as here, or you mark it as non-abstract, and then you say list of string, yeah, and you mark it as abstract, sorry. And then what you could do here is you could say abstract course, and then it's going to say change constructor invocation, right? And then what you have to say is override, otherwise it's going to complain. And this way you have like your abstract class with members which do not have an actual implementation. And then you have an open class, which is course, which inherits from the abstract one and overrides it. And then you can have finally an online course. Of course, we have to use constructor invocation, and at this point we could also override the function of listing students with new people, like this. So let's type it over here. I don't want to type any course now, but object, but I want to use online course object, and then print the list of its students. And as you can see here, we have more students for online course, and on any course we only have 2. So I hope this was enough for you to understand how abstract classes works and classes in general. And I hope I'm going to see you on the next video. Thank you very much, guys, for watching, and I hope you will stick to it and subscribe to the channel when if you want to see more. Thank you, guys. Bye.